This is some review of what we did yesterday, and as well as the quotient rule. So first of all, find the derivative and where f of x would have a horizontal tangent. Please remember that a horizontal tangent means the slope is 0. Well, for us in calculus, remember the word slope and derivative are interchangeable. So we also know the derivative is 0. So, first thing we need is the derivative. And we know our power rule now, so we just say that this is 10x plus 3. Okay. So now I'm going to set that equal to 0. Subtract 3. Divide by 10. And this, negative 3/10, is where the parabola will have a horizontal tangent. Okay. Next, derivative is 3x squared minus 8x plus 4. You certainly have some options here when you set that equal to 0. You could, of course, use quadratic formula, maybe complete the square. I think I'm going to try and factor it. Let me just see if that works out. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Negative 2 times x is negative 2x. Well, negative 6x minus 2x is negative 8x. Negative 2 times negative 2 is 4. So this is it. And being as we want it to be equal to 0, remember that to be equal to 0, one of these two factors must be 0. So we have a choice. X can either be 2 or x can be 2/3. Because 2 minus 2 would make this parentheses 0. 2/3 would make this parentheses 0. These are where we'll have horizontal tangents. Hopefully that makes sense. With a cubic function, if I just sketch a cubic real quick, of course there could be 2 horizontal tangents. Whereas with a parabola like this, there will only be 1. Next, find the derivative. Well, here we've got a product. We can't really expand it. Okay, so I'm going to just do a little bit of coloring here. Got our first piece, and this will be our second piece. Okay, so our derivative will be the first multiplied by derivative of the second. Now, the derivative of cosine is negative sine of x. The derivative of 2 cosine x is just negative 2 sine x. Plus the second multiplied by derivative of the first, and the derivative of the first is just 15x squared minus 7. And this is our derivative. Okay. So again, first times derivative of the second plus second times derivative of the first. Today we're going to look at quotient rule. I just want to briefly talk about the proof, but first let's just look at the formula. If we're taking the derivative of a quotient, a function divided by another function, we do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Okay? Denominator times derivative of numerator minus numerator times derivative of denominator, all over denominator squared. Okay? Call this the high because it's the numerator. Call this the low because it's the denominator. Low d high minus high d low, cross the line, and square the low. Okay. Now the proof looks something like this. Let's start with a function that we define to be u divided by v. I could, through a little cross multiplication, little algebra, I could also say that f times v is equal to u. Well, now I use product rule. Derivative of u is equal to first derivative of the first times the second plus the second times derivative of the first. That's just product rule. Then I can rearrange the terms, subtracting f times v prime over. Okay. Now you'll notice that back at the very beginning I defined f to be u divided by v. So now in this next step I'm simply going to replace the f with a u divided by v. So I have u prime minus f times v prime equals f prime v. Okay. Well, a fraction times a number, we just multiply the numerator in, so that becomes u prime minus uv prime over v. Then I get a common denominator right here. Okay, common denominator. V times u prime minus, or over v minus u times v prime over v. I can rewrite that this way because they have a common denominator. I just find the difference in the numerator, divide by v. You'll notice I still have f prime times v. So I divide both sides by v. That's how I get the v squared. So you'll see here I've got low d high minus high d low, cross the line and square the low. We're at the proof. Low d high minus high d low, cross the line and square the low. Just remember, the numerator is the high, the denominator is the low. Low d high minus high d low, cross the line and square that low. A couple examples. If I want to find the derivative, we do the low. D high. Well, the derivative of the high is just negative 5. Minus high, d low. The derivative of x plus 2 is just 1. Cross the line and square that low. Okay. Now, let me just do a little simplifying on the top. Okay. It will be negative 5x minus 10 plus 5x all over x plus 2 squared. Of course, the 5x's are gone, and my final answer is just negative 10 over x plus 2 squared. Remember how much work doing fractions was with the old definition, and now it's just that easy. Just low d high minus high d low, cross the line and square that low. Okay. Let's quickly do this one as well. F prime low d high. Well, the derivative of 2 is 0, so this whole thing's going to drop off. Minus high d low, derivative of the low is 4x plus 4. Cross the line, square that low. Okay, let me clean up that numerator a little bit. Of course, this whole thing is gone because it's just multiplied by 0. Negative 2 times 4x plus 4 becomes negative 8x minus 8. Bottom we're not going to do anything with. Now I know in pre-calc, oh, I forgot to square it over here, just a second. I know that they talk to you a lot about actually multiplying these things out. In calculus, we don't want to. We often want them in their simplest factored form. So I would not multiply these denominators out. It does not help us to know it's x squared plus 4x plus 4, or that this one is, 4x to the fourth. That doesn't help us. This is what we want, okay? So please do not multiply it out. Leave it in factored form. You don't need to square it out. Just remember, low D high minus high D low, cross the line, and square that low.